Hi there, welcome to edupediaworld.com. In this video, we will discuss about the polynomials factorization. So, how to do factorization using two scenarios. One is factor theorem. First, we'll learn about factor theorem, how to use and apply factor theorem. Then we'll learn how to do factorization by splitting the middle term. So, which is very common. You must have done in previous classes also. Then at the end of the video, again we'll discuss about some of the advanced questions and concepts. So again we'll discuss each and every concept through example. So let's get started with the first concept, which is factor theorem. Okay, now listen carefully. Suppose we have a polynomial px whose degree is greater than 1, like we can say 3x plus 1. Now if a is any real number, means it can be any number like 1, 2, 3, 4. So if x minus 1 is a factor of px, this means that suppose we have this polynomial at px equals to 3x plus 1, and we find the value of this polynomial at some real number, say like we find it value at minus 1 by 3. So what we get is p minus 1 by 3 will be equals to 3 into minus 1 by 3 plus 1. So the answer will come out to be this and will cancel, minus 1 plus 1, which is equals to 0. So this means p minus 1 by 3 is a 0 of a polynomial. So this can be written as x equals to minus 1 by 3. Now we have done is like we have proved that p at minus 1 by 3 is a 0 of polynomial. So this means this can be written like this. So x plus 1 by 3 equals to 0. This means this is a factor of this polynomial. So this is a factor theorem. We use zeros of polynomial to find the factors of any polynomial. So we'll discuss this concept more using in one example. So let's see this example. So now we have one example. We have to examine whether x plus 2 is a factor of this polynomial. So now if x plus 2 is a factor of this polynomial, this means this should be 0 of this polynomial. So let's check it. Let p of x equals to x cube plus 3x square plus 5x plus 6. So now we have another polynomial g of x equals to x plus 2. Now to check whether this is a factor of this polynomial, so we have to do is we have to equate x plus 2 equals to 0. So x will be equals to minus 2. Now we have to put this value in this polynomial px. So this implies is p of minus 2 will be equals to minus 2 whole cube plus 3 minus 2 square plus 5 minus 2 plus 6. So this comes out to be minus 8 plus 3 into 4 plus 5 into minus 2 plus 6. So this comes out to be minus 8 plus 12 minus 10 plus 6. So the answer is 4 minus 4, which is equals to 0. So this implies is this is a x plus 2 is a factor of this polynomial. Why? Because we are getting remainder as 0. We are getting it as a 0 of a polynomial. So this means this x plus 2 factor completely divides this polynomial. So this is factor theorem. Now let's discuss one more question regarding factor theorem only. Now here we have one more question. We have to find the value of k if x minus 1 is a factor of this polynomial. Now if let p of x equals to 4x cube plus 3x square minus 4x plus k. Now it is given that x minus 1 is a factor of this polynomial. This means x minus 1 will be equals to 0, so x will be equals to 1. So we have to find a value of p of 1 which should be equals to 0. Why? Because x minus 1 is a factor of this polynomial. So this implies is what? So this implies is p of 1 will be 4 1 cube plus 3 1 square minus 4 1 plus k will be equals to 0. So this comes out to be 4 plus 3 minus 4 plus k, which is equals to 0. So this and this will get cancelled. So it will be 3 plus k will be equals to 0. So k will be equals to minus 3. So this is the value of k. This is how we use factor theorem. Now let's get started with the next concept, which is factorization by splitting the middle term. So listen carefully, this is very important concept which is normally used in polynomials a lot. So let's get started. Now suppose factorization by splitting the middle term has some certain criteria and steps to check. We have a general equation ax square plus bx plus c. Now how to split this? Suppose we have a general equation ax square plus bx plus c. First always we have to check what is the sum and product. So how to check what is the sum and product? So sum will always be equals to b. The sum is always the next power to the degree of a polynomial. Suppose here we have degree 2, then the next power is 1. So whatever the coefficient of that power is a sum of the polynomial. And what is a product? Product is a multiplication of this and this. This means it will be equals to a into c. So this is how you check sum and product. So we'll explain the splitting the middle term through an example. So listen carefully. Now here we have an example 2x square plus 7x plus 3. Now using the splitting the middle term, first we have to compare with the general equation, which is ax square plus bx plus c. So here we have a equals to 2, b equals to 7, c equals to 3. So again we have to write sum and product. So what is the sum? Sum is 7, and what is product? Product is a into c, which is 2 into 3. Now the next step is we have to break 6 such that the product is 6 and the sum is 7. So how you can do is, suppose if we break 6 into like 6 into 1, so it actually proves and verifies that both the sum and product. How? Let's see. Product of 6 into 1 is 6 and the sum of 6 plus 1 is 7. So it satisfies both the criteria. 6 plus 1 is 7, 6 into 1 is 6. So this means we have two factors 6 and 1. So this is how you split the middle term. So we can write 2x square plus 7x plus 3. So this will become 2x square plus 6x plus x plus 3. Let me explain once again. We have product 2 into 3. We have to break the product such a way that the multiplication of two numbers gives the product and the sum of the two numbers give the sum. So in here we have broken 6 into two parts, 6 into 1. since the multiplication of 6 and 1 is 6 and the sum of 6 and 1 is 7, and see, and it satisfies actually both the criteria. So these two numbers can be used as a factors. Now in the next step, what we have to do is we have to make a pairs, like we make a pairs of 2x square plus 6 and x plus 3, and then we have to pull out the common parts from this pairs. Now we have two pairs, 2x square plus 6x and x plus 3. So what we can pull out from these two pairs, we have x common over here, x common over here, we can write x, and we have 2 and 6. So if we pull out 2 common, what will remain? We'll get x plus 3. Why? Because 2 into 3 is 6. So we get this plus. Now in these two numbers we have nothing common, so we take 1 as a common, so it will come out to be x plus 3. Now in the whole equation we have x plus 3 as a common part, so we take x plus 3 as a common part, and whatever left we write like this. So this is our final answer, the factorization of this polynomial by splitting the middle term. Now let's discuss one more question regarding the splitting the middle term and factor theorem, so that you can get better understanding. Now we have to factorize this polynomial by splitting the middle term and by using factor theorem. Now we'll first use the splitting the middle term. Splitting the middle term. Now we have polynomial 6x square plus 17x plus 5. Now again we have to compare this with the general equation ax square plus bx plus c. Now here we have a as 6, b as 17, c as 5. Again the sum is 17, product is 6 into 5, which is 30. Now we have to break 30, the number, in such a manner that it satisfies both product and sum. Now see, if we break 30 like this, 2 into 15, the product is 30, satisfy this criteria, and 2 plus 15 gives what? 17, so it satisfies the criteria of sum. So these two numbers 2 and 15 satisfy both the criteria. So these two numbers can be used as factors. So we write like this. So again we have to make pairs. We make pairs. Then we take common out. So we take common out 2x, it will give 3x plus 1. Then we take 5 as common out, it will give 3x plus 1. Then in the whole equation we have 3x plus 1 as common, so we take it out and we get 3x plus 1 into 2x plus 5, which is a factorization of the polynomial by using the splitting the middle term. Now in the next scenario we'll discuss how to use factor theorem. Now we have polynomial 6x square plus 17x plus 5. Always remember, when using factor theorem, we have always remember we have to make this number as 1. So what we'll do is we'll divide the whole equation by 6. So what we get is 6x square by 6 plus 17x by 6 plus 5 by 6. So what we get is we get x square plus 17 by 6 x plus 5 by 6. So this is our equation. Now next part, what we have to do is we have to check the product. So when using factor theorem, this is generally a product. This means AC, the product we are using in a general equation, is 5 by 6. So in factor theorem, we have to apply hit and trial method to check the uh, factors. So how you do is we get a hint over here that the product of the factors is 5 by 6. So this means the factors can be 1 by 2 or 1 by 3. It can be both plus minus, right? Or the product can be what, like it can be plus minus 5 by 6. So this is how you have to apply the factor theorem. Now suppose we check at p of minus 1 by 3. So when we apply p of minus 1 by 3, what we get is we get minus 1 by 3 whole square plus 17 by 6 into minus 1 by 3 plus 5 by 6. So what we get is 1 by 9 minus 17 by 18 plus 5 by 6. So what we get is next we have to take an LCM. So what is LCM of 9, 18 and 6? So it will be 3 3s are 9, 3 6 are 18, 3 2s are 6, 3 1s are 3, 3 2s are 6 and 2. So LCM is 2 into 2 4, 4 into 3 12, 12 3s are 36. So LCM is 36. So here it will come out to be 4 minus, here it is 34 plus, it will be 30. So it will come out to be 34 minus 34 upon 36. So the answer will be 0. So now see, we are getting p of minus 1 by 3 as 0. So this means x equals to minus 1 by 3 is a factor of this polynomial. So this means x plus 1 by 3 is one factor. Now we have to find another factor. So how you will do is we have to again check the number. Now if we see this number can be written as 5 by 2 and 5 by 3, both plus minus. So we have to again apply hit and trial method. So we'll use p of minus 5 by 2. So it will come out to be minus 5 by 2 square plus 17 by 6 minus 5 by 2 plus 5 by 6. So the answer come out to be 25 upon 4 minus 85 upon 12 plus 5 by 6. Again we have to take LCM of 4, 12 and 6. So LCM is 4, 12 and 6. So LCM is 4 1s are 4. Sorry, we have to use 2, 2 1s are 2, 2 6 are 12, 2 3s are 6. Then again 2 1s are 2, 2 3, 3. It will come out to be 3 1s are 3, 3 1s are 3, 3 1s are 3. So LCM is 12. LCM is 12. So it come out to be 75 minus 85 plus 10. So the answer comes out to be 85 minus 85 upon 12. The answer is 0. So this means this is again a factor of this polynomial. So x equals to minus 5 by 2 is a factor. So x plus 5 by 2 is a factor. Now we have to stop over here. Why? Since the degree of a polynomial the degree of a polynomial was 2. The degree of polynomial was 2. So we have two factors only. So we have got the two factors. This means the polynomial 6x square plus 17x plus 5 can be written as x plus 1 by 3 into x plus 5 by 2. So this is how you apply factor theorem to factorize a polynomial. Now in the further we will discuss some of the advanced questions used in factorization. So please watch this question carefully because these questions generally come in exam. Now suppose we have to factorize this polynomial. Now to factorize these type of questions you have to use very smart tricks. So there is no general formula to solve these type of questions. So you have to apply rearranging, splitting the middle term, everything, every part you can apply in these type of factorization questions. So let's get started. Suppose we have to factorize this question. 2y cube plus y square minus 2y minus 1. So what we can do is we can rearrange these questions. So we can arrange this number with this number and this number with this number. So what we'll get is we'll get 2y cube minus 2y plus y square minus 1. Then what we can do is we can make a pairs, and again we can take common out. So what will be the common out part here? It will be 2y. So what we'll get is y square minus 1. Nothing is common over here, then we take 1 as common. So we get y square minus 1. So again we have y square minus 1 as a common part. So what we'll get is y square minus 1 into 2y plus 1. So what again we can factorize this polynomial. So we have learned identity which is known as a square minus b square in previous classes. This can be written as a minus b into a plus b. So we can apply this identity over here. So it can be written as y minus 1 into y plus 1 into 2y plus 1. So this is the easiest way to factorize any polynomial. Since factor theorem or these type of concepts are very long concepts, so to factorize any polynomial generally apply these type of concepts. So now we'll discuss one more question regarding this only. It is also a very important question and it's a very good question also. So without actual division we have to prove that this polynomial is divisible by this polynomial. Now if this polynomial is divisible by this polynomial, so this means this polynomial should be factor of this polynomial. So how you'll do is, let's see, let p of x equals to 2 x raised to power 4 minus 5 x cube plus 2x square minus x plus 2, and we have another polynomial g of x equals to x square minus 3x plus 2. So what will be the further step is we will factorize, first we will factorize this polynomial. So how to factorize? We can factorize it using splitting the middle term. So it will be x square minus 3x plus 2. Here the sum is minus 3 and product is 2. So how you can break is, you can write it as any idea, you can write it as minus 2 minus 1. Why? Because minus 2 into minus 1 it will give product as 2, and minus 2 plus minus 1 will give minus 3. So we can write like this. Then we can make pairs. So at the end we can take common out. it will come like this. So here we can take minus 1 common out. Why? Because we need x minus 2, but the given part is minus x plus 2, so we take minus 1 common over here. Then we can take x minus 2 common from whole the equation, so it will give out to be x minus 1. So we have got the two factors of this polynomial. So what we'll do is we'll put these factors in this polynomial. So how to do this? Now what we'll do is first we'll find the value of p of 2. So what we'll get is we get 2 raised to power 4 minus 5 2 cube plus 2 square minus 2 plus 2. So what we'll get is 2 into 16 minus 5 into 8 plus 2 into 4 minus 2 plus 2. So this and this will get cancelled out. So what we'll get is 32 minus 40 plus 8. So answer is 40 minus 40, which is equals to 0. So what we're getting is zeros. This means this is also a factor of this polynomial. Now we'll check for the another part, which is x equals to minus 1. So we'll do over here. So we get is p of 1 equals to 1 raised to power 4 minus 5 1 cube plus 2 1 square minus 1 plus 2. So what we get is 2 minus 5 plus 2 minus 1 plus 2. So what we'll get is minus 3 plus 1 plus 2, which is minus 3 plus 3, which is again 0. So this means this is again a factor of this polynomial. So what this imply? Now this implies that both the factors of this polynomial completely divides this polynomial. Why? Because for the factors of gx 2 and 1 we are getting remainder as 0. This means these are the zeros of polynomial, and again when we are getting a remainder as 0, this means these two factors x minus 2 and x minus 1 completely divides this polynomial. So these were the some of the advanced questions and some of the concepts related to factor theorem and factorization by splitting the middle term. Once again, thank you for watching the video on Edupedia world.com. Have a nice day ahead.